So after vBond is vSmart. We can say that the vSmart controller is the one which oversees every control plane related aspects of Cisco SD-WAN network, overlay network. This provides control for the flow of data throughout the overlay network. That is why we call control plane of network. It provides the mean of it provides the instruction, it provides the mean to control the flow of data throughout the overlay network. So we know that control plane is responsible for what? If you take normal routing, what is the control plane responsible for? To distribute routes. Same way here also, the control plane is responsible for distributing reachability, means routes, and security information between the WAN edge routers. So to enforce this control plane policy, to perform the best path calculation for non-ECMP routes, and advertise the best route to all other WAN edge routers, we got control plane. So it is the duty of control plane is to provide the best path, a policy-based path selection, and the path needs to be advertised to all the WAN edge routers. All this is taken care of by vSmart. Yeah. So control and data plane policy is being advertised between the WAN edge routers. So these are the responsibility of a control plane, which I just told you. It provides the reachability and security between the WAN edge, enforces the policy in path selection, advertises the best route to the WAN edges. When we have non-ECMP, non-equal cost multipathing, the best path is elected. It is control plane. Right, this vSmart is actually a virtual appliance like VM and like vManage and vBond. This is also virtual appliance that provides the control plane for the network fabric. So based on the control plane, the data plane between the WAN edges, the data plane encryption between the WAN edges are propagated, say, in a centralized manner. Yeah. So the control plane determines the data plane. So the data plane information of WAN edges are distributed from a centralized place called vSmart controller. How? This vSmart controller receives the policy from vManage. vManage provides the policy information to the vSmart. And this vSmart distributes them, disseminate, distribute, distribute it to the managed routers with the help of overlay management protocol. So all those WAN edges that has got OMP adjacency with vSmart and vice versa, they are going to get this route information, and this is per VPN basis. So OMP, we learned OMP earlier. OMP is the protocol which carries the control plane information to the data plane called manage. OMP runs between vSmart and manage. So we can call vSmart controller acts like an intelligent IGP route reflector. It acts like a route reflector in the sense that as a centralized point for the entire ACI, not ACI, SD-WAN fabric, overlay fabric, as a centralized point of control plane, it does the route exchange. This is going to improve the scalability of SD-WAN network. See, if you know what is route reflector, you understand the scalability. So when we say vSmart is like a route reflector in BGP, there in BGP we use route reflector to provide scalability. Here also the same purpose. A centralized point of control plane peering and route exchange, which is going to improve the scalability of SD-WAN network. How? For that, first of all, we should know very clearly how route reflector, which is a centralized control plane route exchanging device that improves scalability. You see, we have WAN edge routers. In BGP also we will have similar EBGP routers. This will be EBGP routers. We may have multiple EBGP routers that learn the route from other autonomous system. And these routers will have adjacency only with vSmart. All the EBGP routers, means all the edge routers that connects to various autonomous systems. They learn route from various autonomous systems, and they don't advertise to all of them inside the local. Instead, they will all advertise to the vSmart, means the route reflector. And route reflector will distribute it to rest of the IBGP neighbor. vSmart is same like route reflector. vSmart has got the policy from NMS, from vManage. As the WAN WAN edge routers advertises their LAN network to the smart controller. They apply the policy and distribute the route to all other WAN edges. So the routes coming from LAN 1 will be available in LAN 2 for reachability, but that reachability is not via vSmart. The reachability is via the transport that is there in the middle. But as a centralized controller, vSmart has taken the role of collecting all the routes, collecting all the networks of every WAN edges, applying the policy to it, accordingly choosing the best path and dictating those best paths to the WAN edges so the WAN edges can follow those paths. The data plane is determined here now in a very smart manner. So we can call vSmart as a similar to the traditional route reflector. In a large service provider environment, we use this layer 3 VPN tunnels to the route reflector, and the route reflector reflects the route learned from one WAN edges to one from one edge routers to the other edge routers. That improves the scalability. So we call this vSmart as similar to the route reflector by keeping this OMP that we saw the previous slide, overlay management protocol, which carries a lot of which carries a lot of route information, yes, but more than the standard routing protocol. We learned long back like OMP not only carries route information, it also carries TLOG and much more. So this makes the vSmart controller a very intelligent route reflector. The main difference between BGP route reflector and the vSmart controller is vSmart controller will not choose single path if all attribute fails. You remember BGP is going to pick only one single path out of any number of paths that is available to the destination. The attributes in BGPs are designed to choose only one path. Whereas when we have equal path, the vSmart controller is capable of advertising 1 and 16 equal paths. So vSmart, if policy allows, it can advertise up to 16 paths for one WAN edge to reach the other WAN edge. Up to 16 paths. Whereas BGP route reflector, only one. So like all other routing protocol, even in vSmart, it advertises 4 equal cost paths. The default is 4. If you're from Nexus background, or if you know EIGRP or Any routing protocol, you will know the default equal cast path will be 4. Even here, the control, the yeah, the control plane, the vSmart controller advertises 4 paths by default for destinations if they are found as equal in metric. Fine. So you can increase up to 16. Okay. One more very important thing about vSmart is vSmart exchanges or acts as a key reflector. Key reflector. Or you can also say another job of vSmart is rekeying. So this vSmart, it receives the data plane encryption key. Do I have that? It receives the data plane encryption key from the WAN edge routers and reflects them to the other WAN edge routers. But means to the relevant WAN edge routers. Yeah. So this is another job of vSmart. It reflects the key from one WAN edge to the appropriate remote WAN edge, relevant remote WAN edge router that needs to send the data plane traffic. So more we will see about these things in coming class. Rekeying, key exchange, all the stuff. So we have just finished seeing this point. Oversees the entire control plane. So in order to remain synchronized, the vSmart controller establishes a full mesh control connection to the WAN edge router because the vSmart controller themselves. What I mean is, sorry, you may have more than one vSmart. All right, we may have more than one vSmart if you want. So in order to remain synchronized, the vSmart controller establishes full mesh of control connection to the WAN edge routers, even between the vSmarts. Full mesh helps to have a synchronized database. Each vSmart controller establishes a permanent DTLS connection to other controller called orchestrator, to the vBond. Do I have a picture for that? No. So there's a DTLS connection, a permanent DTLS connection between the vBond and the vSmart. This connection allows the vBond orchestrator to track which vSmart controller is present and operational on network. As I said, you can have more than one vSmart. The DTLS, the permanent DTLS connection with the orchestrator, the vBond, will help vBond to know how many vSmarts are currently active, currently operational, currently present. If one vSmart controller fails for some reason, the orchestrator will not provide the address of that vSmart controller which is unavailable to WAN edge router that is going to join from now on. So vSmart controller maintains a permanent DTLS connection to all vBond orchestrator. This is a very important point to know. A permanent DTLS connection. Why do we need? So that vBond will know which vSmart is present, which one is apt. The permanent connection allows vSmart controller to be continuously aware of any change in the network topology. And maintain a central authority role over the SD-WAN network. So whenever we have more than one vSmart controller like this in SD-WAN domain, the edge routers receive the same information from vSmart controller. Therefore, each WAN edge router is able to continue to route the traffic if one of the vSmart controllers should fail. These are tightly connected, they are synchronized. It's the same information going to come from both the vSmart, full mesh, so even if one of the vSmart fails, not a problem, there is other vSmart to continually provide the control plane information. Redundancy. So we got redundancy. So how is this possible? We have a common domain ID. Right. So about the domain ID, I am not prepared yet, but I'm just giving you an idea. We'll talk about that in the next class. So within a domain, the recommended within a domain, they get synchronized and there is a redundancy. So each WAN edge router can connect to more than one vSmart controller. That's the important point that we learn here. The group of vSmart controller will be in active state. With a pair of smart controllers. Each WAN edge router has got a DTLS connection to both the vSmart controller. So that's how the route distribution happens to all the WAN edges. Right. The WAN edge routers will create a hash between the two connections. That helps them to ensure that the table is synchronized. Right? So WAN edge routers will create a hash and connect it to two of this redundant vSmart controller. So that helps, that hashing, that helps to have a single copy and synchronized copy of the control plane information, no duplication, and they all have a same domain ID. Fine. So what is important is when we have two identical or pair of vSmart controller in an active state, it's important to have an identical control plane, if they don't have identical control plane, then a different vSmart controller could give different information to the WAN edge devices. Therefore, we need to make sure the vSmart controllers must synchronize the information between each other. Now, how do we have the identical view of the topology? vSmart controller exchanges OMP messages between them. The OMP messages helps them to have a single policy, single control plane, OMP messages or the key over the DTLS, the permanent DTLS. So it's the role of vBond orchestrator to inform each of the vSmart controller about the vSmart controllers in the domain. So one vSmart knows about the location of other vSmart through this vBond, the orchestrator. So vSmart controller in the domain, they all know each other, they are synchronized. Not only that, have you gone through this protocol? Have you come across this protocol called Gateway Load Balancing Protocol, GLBP? If you see GLBP, you can have multiple gateways with one common IP address as a first hop redundancy gateway. GLBP is not like VRRP and HSRP. In HSRP and in VRRP, one will be master and other will be backup, or one will be active and the other will be standby. One will be active, the other will be standby. Whereas in GLBP, if you take GLBP, this is our LAN. When the LAN is connected to more than one gateway, between these two, one router will be an AVG as well as AVF. Let's say AVF1. And the other one cannot become AVG. There can be only one AVG, but this is going to be AVF. What is AVF? Active Virtual Forwarding. So in a LAN, if you have 100 computers, for example, AVG will dictate, AVG will tell G1, you are responsible for those odd. See, I have 100. Odd means what? 1, 3. So AVF 1 is responsible for all odd computer. When all odd computers communicate, AVF 1 will be the gateway, which means G1 will be the gateway. For the system 2, 4, 8, 10, all the evens, this will be the AVF. So 50% of traffic will go via this gateway, 50% of traffic will go via this gateway. So the confusion is no more. Whether to go via left or right is well determined. Who takes care of this? AVG takes care of this. AVG says, okay, fine, we are two gateways now. One cannot take all the load. So let me tell you who will take care of whom. So AVG says to gateway 1, you are the virtual forwarder 1, and you will be responsible for these MAC address. If traffic coming from these MAC address, you take the role of gateway. And also it tells AVF2 that you take the remaining MAC address. Any traffic from and to the remaining MAC address, you will be the gateway. Likewise, the vSmart controller in the domain tell each the vSmart controller which WAN edge router in the domain it should accept control connection from. See, we got multiple vSmarts and multiple WAN edges. Which WAN edge? Which vSmart? Or who is going to be responsible for whom? So within a domain, this vSmart may be responsible for this WAN edge and this WAN edge. This vSmart takes responsibility of this WAN edge. No, they share so that there won't be duplication. So those things are determined in vSmart controller itself. The vSmart controller tells each vSmart which WAN edge router in the domain they should accept the control connection. So whenever we have redundant vSmart controller, they need to have identical control policy, but not all WAN edges are going to be mapped to each vSmart. The vSmart controller will divide the load and they take. So in case if one of the vSmart goes down, or let's say all the vSmart controller fails because of some unreachability issues, all the vSmart controllers have gone down. What will happen? Will the routers work? Will the WAN edge routers continue their operation? Yes. So the WAN edge routers will continue the operation on the last known good status. So to an extent, to a considerable amount of time, they keep running. They don't immediately go down. So the data plane activity will not be affected. They keep running. And this is known as graceful restart. See, you might have learned graceful restart in EIGRP, OSPF. In SD-WAN, this is the meaning for graceful restart. Even when all the vSmart control goes down, the data plane activity will be still green, will not be affected. However, you remember vSmart is also responsible for rekeying to establish connection between the IPsec connection between WAN edge router. What is important? Rekeying is important. After 1 hour, by default, the rekeying happens in IKE phase 1. Who is needed? And vSmart is needed. So, because there is no rekeying, there is no policy exchanged, this cannot continue for a long time. It's graceful restart. Fine. So it's OMP the one which is running in between via the permanent DTLS connection. To provide high availability in control plane of Cisco SD-WAN solution, this DTLS and the OMP control plane protocol is involved. This is not new to us. We already learned that OMP is built on top of DTLS between the devices, and this DTLS is monitored by OMP protocol by creating OMP peering. OMP is same like BGP session. So in SD-WAN, OMP is the very important routing protocol. So a reminder, OMP, they don't run in between the WAN edge routers. OMP does not run between the WAN edge devices. It is the IPsec, the one which runs between the WAN edge router. OMP is just a control plane that runs between the control plane components like vSmart and WAN edge, but not between the WAN edge. So OMP gives the SD-WAN a consistent view of network by synchronizing the route information end to end. So OMP carries a lot of parameters, a lot of informations, and share them over the OMP peering session to the vSmart controller and the WAN edge router. OMP also monitors the status of all SD-WAN devices in the network and automatically adjusts to change the topology device whenever a new SD-WAN edge device comes online or whenever a WAN edge leaves. It is the OMP, the one which monitors the status of every device and changes the topology so that the conversions can happen accordingly. So the control component redundancy. We have device redundancy by having more than one vSmart controller, and we use OMP over DTLS control plane redundancy. So it's the OMP, the one which helps to detect when there is a device failure, when there is failure in event. When vSmart becomes unavailable, the vBond will know that there is another vSmart. So it gives the IP address of only the other vSmart to newly coming devices. OMP helps Fine. Next is the last component of our SD-WAN. So far we have seen three: NMS, we manage; orchestrator, we bound; control plane, controller called vSmart. Now the data plane, the last one, the WAN edge. The responsibility of data plane. Data plane provides the infrastructure for sending data among the WAN edge routers in the SD-WAN overlay network. Data plane is used to transfer the route traffics from one WAN edge router to the other WAN edge router. So most of the time, if you see the traffic that moves from one WAN edge to the other WAN edge is IPsec. It may be using an internet as a transport, but the tunnel is a secure tunnel. It may be over MPLS transport or internet transport. So there's a secure tunnel provided between the WAN edge routers. It's a wonderful data plane that the SD-WAN can provide. IPsec is a security protocol that helps to form a secure channel between the WAN edge routers. Yeah, see here, a secure tunnel. So before they exchange any application data traffic, what is important is they have to establish an IPsec connection between these WAN edge routers, between themselves. So the WAN edge routers, they try to form full mesh IPsec connection in order to establish the network fabric, and then route the data traffic across the site over the overlay network. So within the data center, we have WAN edge routers such as Cisco VH, means Webtela Edge, or Cisco C Edge, which is Cisco Edge itself. We have Cisco's own ASR devices, ISR devices, which are called as C Edge devices, which is also software based. C edges are software based. V edges are Webtela or physical box. So we have WAN edge devices, both software as well as the hardware. Now, this WAN edge routers can reside in a number of locations, but still they can communicate via SD-WAN overlay. Sites are not in same city, same metro, various locations. So it may be in data center, it may be in a remote site, it may be in a remote campus, or it may be even in a cloud. Fine. Now, these WAN edge routers have got multiple tables. One is RAIB. the routing information base that are populated automatically with a direct interface that are connected, static routes, dynamic routing protocols, learned routes like BGP routing protocol, given route OS. So RIB is something which is dynamically built. This is not only applicable for managed router, for any router. RIB, if you have two physical connection, you will have two network in it. So RIB is now built with two networks. RIB may also have more network if you have routing protocol running in between this device between this device and the other device. So what route need to be there in the routing table, what not to be there, all are determined by the route policy. If you don't have any route policy, then all routes that are given by the neighbor routing table will be available. But if you have a route policy, that will affect the routes that are going to be stored in RIB. Those BGP students, you will understand what I mean. Need not to be BGP student. In BGP, you can easily see according to the AS path attribute or origin or reachable next hop address. The BGP forwarding table will decide what will go into RIB. So route policies can affect which routes will be going inside, which routes are going to be stored in RIB, routing information base. So we also have a FIB, forwarding information base. This is what the WAN edge routers are going to use to forward packets. Each WAN edge router has one permanent DTLS control plane connection to each vSmart controller in its domain and secure data plane connection to other WAN edge routers. The secure data plane connection to other WAN edge routers is an IPsec. So it is IPsec that are used in the data plane. So this is not dependent, this is totally independent of DTLS connection, DTLS tunnels that are used by the control plane. Fine, the permanent DTLS connection is only established after checking authentication. Sorry. The certificates. The permanent DTLS connection between the vSmart and the WAN edge. The WAN edge and the vSmart is after checking, only after authentication is successful. The connection is used to carry the encrypted payload between the WAN edge routers and the vSmart controller. The payload may contain the route informations that are necessary for vSmart to map as per the policy the routes are distributed. So one point that we learn here is the tunnel between the WAN edge and vSmart is a permanent tunnel after checking the credentials. Fine. Next. The secured session between the WAN edge routers and the vSmart controller and between the vSmart controller is by default a UDP based DTLS. So between this and this, between the WAN edge and the vSmart, these tunnels are 1, 2, 3, 4, 6 port number UDP. Though it's a persistent DTLS tunnel, it is UDP based DTLS. And this is the default port number 1, 2, 3, 4, 6. You can also have different port number, but this is default. You can also use different port number if in case the first connection fails. You can try with the WAN devices will try with different port numbers. For example, when this WAN edge router tries to establish with this port number, if there is no response, he'll try to use 1, 2, 3, add 20 to this, so 66. So in the increment of 20, they keep trying. So you can also use, if you want, TLS connection to vManage and vSmart controller. So it's not if you want, that is the connection. Between the vSmart and the WAN edge, it is DTLS. Between the vSmarts, also DTLS, UDP based. Whereas between the vSmart and the vManage, it is going to be TCP based TLS. TCP based TLS connection. So the data plane WAN edge routers run standard based BFT protocol, which we know very well from the beginning. There's a standard based BFD protocol. This BFD runs automatically on top of IPsec connection between the WAN edge devices. And we know the responsibility of BFD is to measure the performance, the metric of the data tunnel. The health of the data tunnel is determined by this BFD. So BFD runs automatically on IPsec data tunnel between the WAN edge device. That's what we need to know. Now next, the redundancy in WAN edge devices. There are a number of ways that we can have data plane redundancy. But before that, there are a number of ways we can make a data plane redundancy. One is data plane redundancy. Secondly, the transport redundancy also will provide you redundant data plane. So we have site redundancy, transport redundancy, network redundancy, controller connection redundancy, various type of redundancies. VRP protocol, virtual route redundancy protocol. So if a site wants a redundancy, you can use a protocol called VRP. Or you can do some manual load balancing with the help of routing protocols such as BGP. BGP is not designed to do load balancing. But manually, you can write some policy and do some sort of load sharing using local preference or wait attributes. You may use OSPF or even EIGRP. So this is what we also see in the traditional network design. So in short, for site redundancy, what you need is a protocol such as VRRP or routing protocol such as BGP, OSPF, EIGRP. Next is the network level redundancy. The network level redundancy is implemented by multiple geo-redundant database. So we can have multiple WAN edge devices on one side. With full mesh of IPsec connection and BFD monitoring the path. Yeah, so that is another redundancy, network level redundancy. Also, we can connect to multiple vSmart for control connection redundancy. So for transport redundancy, we depend on TLOGs. For transport redundancy, we have TLOG extensions. Yeah. So when we have multiple connections, multiple transports to reach from one WAN edge to another WAN edge devices, like a bird eye view with the TLOG extension feature, we can have multiple paths used together to provide more bandwidth, or we can choose one best path in the runtime over the other. So that is taken care by TLOG. So TLOG is not binded to any physical path. TLOG is binded to the virtual tunnel, the overlay tunnel. So that brings us to the end of. We'll get into security in the next class. So that brings us to the end of components of SD-WAN. We have seen all four components in detail. How many we can have in maximum, what are all the type of connections between the controllers, what all protocols involved, how the redundancy is provided. For example, even if all vSmart goes down, still the data plane activity will be up and running to an extent. If there is any need of IPsec rekeying, then it breaks, because IPsec key is also exchanged via vSmart. For one WAN edge to communicate to another WAN edge, it needs an IPsec tunnel. So IPsec rekeying is only through vSmart. So if no vSmart, no reachability update, no IPsec rekeying, there is no new policy can be propagated anymore. So go through this and the previous class. Those two are very important. Those clearly explains all the four components and the redundancy policies of all four components, in which all four components are software based. WAN edge can also be hardware based. Right? Any question on these components of SD-WAN? Right. No problem.